Hello boys and girls, Mr. Giomini. Wanted to come to you with a couple examples on the con skill that is being assigned, ratio word problems. Today we're going to take a look at two ratios, putting them together to make a proportion where both ratios are equivalent to each other, to make sure that they are proportional. Let's just jump into this and see if we can't deconstruct some of these problems and become successful with these. In geometry class, the girl-to-boy ratio is 9:6. I am comparing young ladies to little boys. We're comparing girls to boys, and the ratio is 9:6. I'm going to kind of come over here and make a little side note. G, which I hope we understand stands for girls. B, which stands for boys. Now I know that there's 9 girls for every 6 boys. So I can count off 9 girls in the class, and then there'd be 6 boys, and then 9 girls, and then 6 boys. Now if there are 27 girls, so we have 27 girls now, how many boys are there? Well, I'm going to keep the information that deals with girls on the top part of the ratio. So I'm going to put the 27 on top. Now, based on what I started with here, I see that I have more girls than boys. So I would estimate that my answer here must be less than 27. Now I'm going to try to find a relationship that's going on between 9 and 27. What must I do to 9 to make it 27? First thing that pops in my head is multiply by 3. Just like we do with fractions, whatever I do to the top part of the ratio, let's do to the bottom part of the ratio. 6 times 3 gives me 18. That does make sense here, because if you think about it, I have 3 groups of 9 going into that. So when I have one group of 9, I have a difference of 3. That means 2 groups of 9, I have a difference of 6. A third group of 9, I have a difference of 9. And 27 minus 18 does give me 9, so it makes sense with my logic here, my thought process. There should be 18 boys. Let's take a look at another one. In chemistry class, the girl-to-boy ratio is 6:4. Again, we're comparing girls to, I like to make the little ratio symbol there, boys. And it's 6:4. So we have girls on the top part of the ratio, boys on the bottom part of the ratio. We have 6 girls for every 4 boys. Now we have 12 boys. Well, we want to know how many girls there are. Again, looking at this proportion over here, I'm going to make this equivalent, these two ratios equal to each other so that they're proportion. I want to say, well, I have 12 boys. Well, the information of the boys was in the bottom of the ratio. Same thing here. I noticed that I always have more girls than boys. That means this answer here must be larger than 12. I asked myself, well, what did I do to 12 to make it, or what did I do to 4 to make it 12? Well, I can multiply by 3. Multiply 3, I get an answer of 18. Now, the other way to solve this, we can kind of look at it as take this and make it into an equation, would be equal to 12, and this is the unknown. I'll put a G here for girls. I can do some cross product. 12 times 6 gives me 72, and that is equal to 4, the other cross product, 4 times G. I would divide both sides by 4. This would cancel out and be left with G. G equals, let's see, 4 goes into 7 one time with, I believe, 3 left over. 4 goes into 32 8 times. We should have 18 girls. 2 different algorithms to solve this problem. Again, you do what you feel most comfortable with. Let's look at another one. In geometry class, the girl-to-boy ratio is 8:5. This is a great see because I always say boys are stronger in math than girls. It's good to see that there's more girls in a geometry class than boys. We're comparing girls to boys in a geometry class. Now, the original ratio is girls 8, boys, oops, that's not a B. I'm putting the 5. We have boys 5. Now it says, if there are a total of 39 students, how many of them are boys? Well, I don't have the total here. What could I do to get the total? So when I'm saying 8:5, that means I've looked at a group of 8 girls, and after I get 8 girls, I should, if I want to put them in order or like a line, I have 8 girls followed by 5 boys, then another 8 girls followed by 5 boys. Well, 8 and 5 would give me then a total. I could just add these two, give me a total of 13 kids. Now, we want a total of 39 students, and we want to know how many boys are there. So we don't need the girls anymore. We're actually comparing the boys to the total number of students in the class. Now, I'm going to start with, when I have 13 students, a total of 13 students, of those 13, 5 are boys. But now the question is asked, well, hey, how many boys will I have if I have 39 students? And this is the total number of students. So 39 goes on the bottom. And then I ask myself, what did I do to 13 to get 39? Well, I multiplied by 3. Whatever I do to the bottom part of the ratio, I must do to the top part of the ratio. 5 times 3 gives me 15. But wait a minute here. Does this make sense with the question I asked? I'm always going to have fewer boys than girls. Well, that means if I had 15 boys, how many girls would I have? Well, if I have a total of 39, 39 minus 15 means I'd have 24 girls. Well, that's okay because I should always have more girls than boys based on this original ratio. Let's try. I have 15 boys total. Okay, let's do 2 more. In language class, the girl to boy ratio is 9 to 4. Again, girl to boy. I'm comparing girls to boys. So the top part of my ratio, or the first of my ratio, should deal with girls. The second number should deal with boys. I'm going to put girls here, boys here. Now, boys and girls, you notice I'm using the ratio a lot in fraction terms. You can also do this. Remember, you can write it like this. You can also write it like this. For me, though, doing these proportions, it's easier for me to have the ratios look like fractions. Now, we have 9 to 4. Now, it says, if there are 18 girls, how many boys are there? Okay, this is great. No need to find a total. Original ratio, 9 girls, 4 boys. I'm always going to have more girls than boys. When I make my proportion, I'm going to say, wait, I have 18 girls. 18 goes on top. I'm asking myself, what did I, because that's the unknown. We don't know how many boys I have when I have 18 girls. What did I multiply 9 by to get 18? Multiplied it by 2. Multiply this through 2, I get 8. Now again, we could do cross product. I could say, hey, 9 times the x, which is the unknown, is equal to 4 times 18, which in my head I can do 72. This is a one-step equation. Evaluate for 1x, not 9 of them. Divide both sides by 9, I would get x is equal to 8. Again, gives me the same answer, just a different algorithm. And let's go one more. In language class, the girl to boy ratio is 9 to 4. A lot of language class. And always more girls. Ratio of girls to boys is 9 to 4. If there are 26 students, I'm dealing with a total here. I have 26 students. How many are boys? Going back to my original ratio, we were comparing girls to boys. That was our original ratio. And we had 9 girls for 4 boys. But now we're talking about, hey, I have 26 students. So that is a total. What happened there? There we go. Sorry about that. That is a total. How am I going to get a total out of this? Well, again, if I'm looking at a class and the one set has 9 girls for every 4 boys, altogether I just looked at 13 kids total. 13 total. Now I'm finding out how many boys there are. Well, if I'm going comparing boys to total. Okay, let's take a look. Originally I had 4 boys. And if I had 4 boys, I had a total of 13 students. We want to make that ratio equivalent to another ratio in this proportion. I now have 26 students, and that's the total amount that I have. Would I multiply 13 by to get 26? Multiplied it by 2. Times the top part of the ratio by 2. 4 times 2 gives me 8. I will only have 8 boys. Let's take a look if I'm right. Okay, I hope this helps you out with this con skill. Take care. Bye-bye.